Hey guys, Faisal here from Faisal and Codes. Today we're going to be taking a look at how to create a partition in our Linux server. We're also going to be taking a look at how to mount that partition to a specific location. So we're going to be creating a directory and then we're going to be mounting it to that directory. We're also going to be taking a look at how to create a logical volume, the non-persistent method, and also the persistent method. So I'm going to explain to you during the video what a non-persistent method is and a persistent method is. All right, so with that being said, let us get started. All right, so I have my virtual VMware workstation open. Before we hop into our server, we're going to go edit virtual machine settings and we're going to add a disk. So right now you can see that we have one disk and this is the boot disk. So the boot disk contains all the files, the directories that is needed to boot the system. And this is a crucial disk that we really need. So now let's add a new disk. We'll click hard disk, next, NVMe, create a new virtual disk. Let's allocate 40 GB to that. And we'll store that as a single file. And this is where you can change the name of the file name, and you can also browse for the location and you can change that. I'm going to leave that default. You can change it if you like. Click finish, click OK to apply the changes. All right, let's boot up our server. And while that's booting up, I'm going to SSH into our server and the remote ng. So, all right, give it a second. All right, let's log in. All right, so we're logged into our server. Before I start, I'm just going to make the font a little bigger. All right, so to view the disks on our system, we do ls blk, and that stands for list block. So you can see that we have our first disk, which is our boot disk, right? And then you can see that we created our second disk, which is just a disk at the moment. There's no partition, which we're going to be creating right now. So I'll be showing you that. So that's our disk name. And this is just a conventional name. All right. So to create a partition, we type in fdisk/dev for device and slash the disk's name. All right, press enter. Now we'll be prompted up with this menu. So let's get some help. We're going to type in M and press enter. Now we have a list of options. So right now we're going to be creating a new partition. So we're going to be going with the N option. So let's type in N for new partition. And now this is where we pick either primary or extended. So we're going to go with the primary. So type in P and partition number, I'm going to leave that blank, or sorry, default. Sector number, I'm going to leave that default. Over here, now we specify how much space we want to give to our partition. So I want to give 10 GB. So I'm going to put in plus and then 10 and then G. If you wanted to give it 10 megabytes, you do M. If you wanted to do kilobytes, you do K, and so on and so on. All right, 10G. And now let's write the changes. To write the changes, we pressed or type in W and enter. Now let's do ls blk list block. And you can see that we have created our partition. Awesome. So now let's try to mount this partition to a specific location. So let's actually create a directory. Make directory parts. I'll call it parts and I'll call it storage. Part storage. Before we actually mount our um, our partition to this location, we need to create a file system. If we don't create a file system, we can't actually mount our partition. So let's create a file system, mkfs, and I'm going to be using the XFS extension for the file system. There's actually a lot of file types, file extensions. So there's XFS, XT2, XT3, XT4, UFS, XFAT, and TFS. All right, so I'm going to go with the XFS, and then I'm going to specify the partition name, not the disk name this time, the partition name. All right, /dev/partition name. Press enter. Awesome. Now let's give it a mount. So to mount, we do a mount /dev for device, and then our partition name, and then the location. So it was parts/storage. Now let's do lsblk, and you can see that our partition has been mounted to this location. Now if I do df disk fix -th, you can see that we have 9.9 G available. So this is our partition. Let's actually allocate some space to this partition. I'm going to be using the dd command. I'm not going to be getting into the dd command in this video. I'm just going to be showing you how to actually add some space. There's actually an example. dd input file dev 0 output file. In this case, it's parts storage files.txt count equals 1024 byte size equals 1024 567. Actually, before I run this command, I'm going to create that file first. Touch parts storage, and then it was files.txt. And then we can run this command. Before I run it, I actually forgot the S in the parts. Awesome. Now let's run that. So now we have allocated 1 GB to our partition. Now we should have 8.9 in total. df th. Now you can see that we have 8.9 G available. So we just put an empty file that was 1 GB of size. Now if I wanted to do 2 GB, I can simply put in 2 there, and that should allocate 2G to our partition. Again, I'm not going to be getting into the dd command in this video. In a future video, I will most certainly be getting into the dd command. All right, so that's how we create a partition, and that's how we mount that partition to a specific location. Now let's take a look at how to create a logical volume. So first I'm going to create another partition, and to do that, fdisk/dev for device, and then our disk name, not the partition name, because we're going to be creating a partition, so we will have to specify the disk name. All right, new primary for P, leave that default, and I'll give this 15 GB. And let's write the changes. Let's make sure we created our partition, and that's our 15 GB partition. Awesome. Now, how do we create the logical volume? So first, we actually need to create the physical volume. And before we create the physical volume, let's take a look at our physical volume on our servers at our server in the moment. PV, display, and at the current moment, we have one physical volume. All right, so let's create it, PV create, and specify the partition. So /dev/ our partition name. And so in this case, I'm going to be going with the NVMe 0 and 2P2, the 15 GB. Press enter. Now we created our physical volume. So if we do Yep, if we do, sorry, if we do a PV display, now you can take a look that we have created a new physical volume and it says it at right over here. All right, so now next we need to create a volume group. To do that, we do VG create. Actually, before we create that, let's do VG display. So let's take a look, VG display. So right now we only have one volume group. So VG create to create the volume group, and then we're going to give it a name. So I'm going to say volume for simplicity, and then specify the partition name. So /dev. Oh, I copied the wrong thing. I'll clear the screen, lsblk. So pv create, oh sorry, vg create volume group create volume name. So the volume name is just going to be volume in this case, and /dev and slash the partition name. Oh, forgot that slash. Awesome. Perfect. Now let's do VG display. Now if you take a look, we have two volume groups. One over here, and this is the one we created. Awesome. Now, the last step is to create the LVM, the logical volume. So to do that, we do LV create, but before I do that, I'm going to actually show you LV display. So right now we have two logical volumes, and if I do lsblk, you can actually see that we have two logical volumes right here, right? And the space, the size actually matches up as well. All right, so let's create the logical volume, LV create, and then we do -L, capital L for the length, and this is where we specify the space or the size. In this case, I want to give it 5 GB, and then we say, and then we put in the name for -N. So for this one, I'm going to give it logical. That's going to be the name, and then we're going to specify our volume group name. So it was volume, since we named our volume group volume for simplicity. All right, we can press enter. Now, if I do lsblk list block, we'll see underneath our partition NVMe 0 and 2p2, we'll see a logical volume underneath this. And there we have it, our logical volume, the name of our logical volume. Again, you can name this anything you like. I just picked volume and logical for simplicity, so you get a better understanding. All right, now let's take a look at how to mount the logical volume. So first, let's create a pathway to mounting it. So make directory p, and I'll call this logical, and I'll call this storage. Awesome, logical storage. And now we need to create a file system. So if we do df th, right now we don't have any file system on our logical volume, so it will give us an error. Or actually it wouldn't let us mount it. So let's actually give it a try. So mount dev, and now we're going to specify the volume and logical, the LVM name. Since we're trying to mount the logical volume, so we have to specify what we're trying to mount, and then we can specify the path where we want to mount it to. In this case, it's logical and storage. So as you guys can see, it says wrong file system type, bad option, right? Yada, yada, yada. That's because we haven't created our file system. So to create our file system, we do mkfs dot the extension or the type of the file system we're using. So in this case, I'm going to be using XFS, and there are actually quite a few file systems. So if we take a look in my notepad, there is XFS. It's helpful for large files. There's X2, X23, XT4, UFS, XFAT, and TFS. I believe there's a little bit more as well. You guys can research into that. All right, so I'm going to do mkfs, make file system, xfs, and then this is where we specify where we want to make the file system. So we want to make it a def, and we want to make it onto our logical volume, which is named volume and logical. All right. Now if I do df.th, now you can take a look. Actually, it still has, still not present. Let me actually try to mount it before. I believe it needs to be mounted for us to see in the disk fix. So let's mount it by running the mount command, and then we're going to specify the specify where we want to mount it, or what device we're mounting, and then we're going to specify the path where we want to mount it. Press enter. Now if I do lsblk, it has been mounted to our logical/storage directory. Now if I do df.th, now you can take a look. We can see our logical volume. The type is XFS. The size we allocated is 5 GB. The actual available is 4.9, and where it's mounted to. Awesome, awesome. So this is the persistent method, or sorry, this is the non-persistent method of mounting. Non-persistent. Now, what is a non-persistent method? So when we reboot our system, the locations that we have mounted it to, they will disappear. They will no longer be mounted because that is the non-persistent method. So the system doesn't know that if it's saved, um, because we haven't saved it in a file, we just simply just mounted it directly. So we just ran the mount command. So when we reboot, there's no actual file being saved specifying, oh, this is where we want to save it. This is the device we're using. This is the file system, since we just mounted it directly on our system. So let me actually show you this in action. So if we do lsblk, right now we have our partition that's been mounted to this part storage, and our logical volume, which has been mounted to logical storage. So let me actually reboot my server. Let's restart. Give it a second. And then I'll SSH into it. All right, let's actually try again. There you go. So now if I do list block, oh, before I do that, let me actually increase the font size. Perfect. So now let's do list block. And now you can see that our mounted path has disappeared. That's because this was non-persistent method. So let's take a look at how to mount it persistently. So when we do reboot the system, the mount point is still going to be there. So to do that, we need to actually save it into a file. And that file is Fstab. So before we actually save it in that file, we need to grab the UUID of this the name of the device. So let's take a look. We do block and then we do ID. So this is the UUID for our logical volume. This is the device name, and this is the UUID. And this is associating, this UUID associates to the name right here, so that the system knows from this UUID, it is this. All right, let's copy this. And let's put this in our file. So our file is located in /etc and it's fstab. File system tab. Press enter. And now we'll scroll down, or actually arrow key down, and I for insert. Now let's paste our UUID. We don't actually need these quotations, so let's take out these quotations. And we need to specify the location that we want to mount it to. So I believe in this case it was logical and it was storage. And then we can press tab and we can put in the file system, XFS. We can press tab. We can leave this default. Press tab 0 and press tab 0. And what defaults in 0 is, it's actually, so there's actually 6 columns. So we got the device name. You can either put the device name or the UUID. I prefer to put the UUID, that way it's specific, targeting that device UUID, right? Then the default mount point. So this is the mount point right here, the second column. Then the file system. Right here, this is the file system. This is the extension we're using, XFS. If you were using a different file system, you'll put in a different extension. This is the mount option. So we're leaving that as default. And this is the dump option. And next is our file system. If you want to get actually a more detailed description, you can head over to this website, which I will leave the description, or sorry, I will leave the link in the description, so you can take a look at the exact columns. So for the fourth column, you can actually give permissions of how you want this device to be operated. Read only, read write, auto, right? So you have a lot of flexibility over here. Awesome. So now that we got that, let's Control C, save it, and write and quit. All right. So let's take a look. Actually, before I do that, let's confirm storage. Yep. Storage. I actually spelled that wrong. It's storage. Awesome. Now let's mount it again. Mount A for mount all, or actually we don't need to include the A flag. We'll just mount /dev and then /volume and logical. Be sure to add that slash in between the volume name and the logical name. Press enter. Now let's take a look. Now you can see that it's been mounted to logical and storage. So over here, we didn't actually have to specify when we were mounting it. We didn't have to specify the location where we're mounting it to because we've already put that location in our file system tab. So there's no need to actually specify it. If you were doing it the non-persistent method, then you would have to specify the location where you're mounting it to. But since we're doing it the persistent method, we don't need to since it's already here. If we go back into Fstab, you can see we're specifying the location where it's going to be mounted at. Awesome. Quit there. Now, if I were to reboot the system, yep, restart guest. We'll give it a second. All right. Awesome. Let me quickly make the font bigger. All right, now let's do lsblk. And now if we take a look, our device is still mounted to logical and storage. It's because we did the persistent method. So now we can reboot the system, we can shut down the system, we can do anything to the system. It'll still be mounted. Actually, let me create an empty file. So if I do df/th, right now we can see that we have 5 GB, well, approximately 4.9 GB available. Let me make a file, touch files.txt in logical storage. Awesome. So I'm going to actually allocate some space. I'm going to make a file with around 1 GB and allocate it inside of our um, mounted point. So to do that, we're going to use the dd command. In this video, I'm not going to be getting into the dd command. I'm just going to be showing you. In a future video, I'm going to be deep diving into the dd command. All right, so dd input file equals dev 0 output file equals logical storage files.txt count size equals 1024 byte size equals 1024 567. Everything looks good. Awesome. Okay, so now we should have 3.9 GB available to us since we allocated a file with 1 GB. Let's do df th. Now we can see that we have 3.9 GB available. We can do the same. We can actually allocate 2 GB instead of 1. And if I do df diskfix th, we can see that we have 2.9 now. Awesome. And if you wanted to see all the mount points, we simply put in mount and -l. And you can see all the mount points on our system. You don't actually need to put L. You can just put in mount and it will do the same thing. But I'm used to putting the L. All right. Now I'm going to show you how to resize the logical volume. So if I do lsblk, right now the size is 5 GB. I want to resize this since we have more available to us, since this is coming from this partition and this partition contains 15 GB in total. So we can allocate more gigabytes to our logical volume since we have that capability. So let's do lv resize size. Then let's specify how much we want to give it to. So I want to give it 5 more G. Oops, 5G. And we're going to specify the location. So, the name. So dev volume / logical. Awesome. Size of logical volume has been changed from 5 GB to 10 GB. Now if we take a look, we have 10 GB on our logical volume. Now, so if I do df th, you can take a look. I don't believe this has been updated yet, so I think, or I believe, we have to reboot the system for this to take effect. So that's why you see 2.9 here. If I do disk usage, logical, just check. Okay, so 2 GB is being used right now in our mount point. All right, you can also similarly do lv extend, and you can do -r for recursive, and then you can do capital L for length, and then you can specify how much you want to give it. So let's say if you want to give it 2 more G plus 2G, and then we can specify the device name. So dev for device, volume, and logical. That's our device name. All right, so now you can see that the size has been changed from 10 GB to 12 GB. So now if I do lsblk, you can see it's been changed to 12 GB. Now you might be asking, well, what's the difference between resize and extend? Why would we want to use both of them? Well, to for the resize, you can actually increase the size and decrease the size when you resize, when you use the resize command, lv resize. And when you do lv extend, that only extends the space. So you can only add to that. You can't decrease it. So let me show you. So if I wanted to do lv resize, oh, spelled that wrong, resize hyphen hyphen size, and then if I do minus instead of plus, and I'll do 5G, actually I'll do 2G, so that way we have 10 GB left. And I'll do device, volume, and logical. And it's going to ask us, do you want to reduce the size? And depending on if you have files in there, directories in there that are important, you wouldn't want to do this unless you're sure of what you're doing. So since we have nothing of importance, we're going to continue with Y. And now we have successfully changed the size from 12 GB to 10 GB, lsblk, 10G. So in most cases, you'd most likely be using the resize command instead of lv extend, but you have an option to use also the lv extend. And if you wanted to see your logical volumes, you can do lv display, right? You can see all your logical volumes. You can also see your volume groups, vg display, and you can also see your physical volumes, pv display. You can also similarly use the fdisk command, and you can do fdisk-l for list, and you can see all the devices on your list all at once. So this is our logical volume right here. Awesome. Let me just confirm. So now it actually has been updated. So I believe, I guess I was wrong. We didn't need to reboot. It just took a second or two for it to get updated. Awesome. So there we have it, guys. That's how you use the LV commands, how to create a logical volume, and how to create a partition, how to resize, and whatnot. So if you guys found this video helpful, give it a like. If you guys have any comments, comment below. I'll see you guys in the next one.